Welcome back, 7th graders, to day 2 of lesson 8.1 on page 417 of your textbook. I can simplify algebraic expressions by combining like terms. So previously we learned about distribution when simplifying algebraic expressions. After distribution comes combining like terms. So this does involve some vocabulary, so please keep that handy. So algebraic expressions, simplifying them. When a plus or minus sign separates the algebraic expression into different parts, each part is called a term. The numerical factor of each term contains a variable, and then that would be called the coefficient of the variable. So there's variables, there's coefficients, there's also constants. So we'll see what all of these are. Like terms contain the same variable to the same powers. For example, 3x squared and negative 7x squared are like terms because they both have x to the second power. 8xy to the second and 12xy to the second are because they both have xy and squared. If one just had y squared and not the x, then they would not be like terms. They have to be the exact same variables powers. So notice here, 10x squared times z and zx times z squared, they're not like terms because x is squared on this one, but z is squared on this one. They are not the exact same, making them not like terms. A term without a variable is called a constant. Okay, so that would just be a regular number. But they can also be like terms, so 4 and 3 and numbers by themselves. So these are 3 separate terms in this figure here. Just the red ones are like terms because they have the same variable. So matching like terms. If we were to match like terms, we could find them. So right here we have 4, which is a constant. I would combine 4. I'm going to just do some color. 4 and 17 are going to be like terms because they are constant numbers. AB, I don't see a like term for that. The reason this is not a like term is because it has this part there. So those are not like terms. X is actually the same as 1x. And so 1x and 3x are like terms. 10g and 4g are like terms. And then 5x y to the second and 7x y to the second are like terms. So the only ones that don't have a like term are this ab squared and just regular ab because they are not the exact same terms. Hopefully that helps you connect some of them. Some of you might have organized this by lining them up because you might not be taking notes with colored utensils, and that's okay too. Organize it as you see best fit. So I can identify the terms, like terms, coefficients, and constants in the expression. So just identify the parts of each expression. So what you do is, with the definition of subtraction, what some people like to do is change all these to chop, minus, so that you see the sign in front of it, which makes them negative signs. So you can see that if they're positive or negative. Some people, and you'll see me do this occasionally, just look at the sign in front. So I just circle and kind of separate it by the sign in front. So I know that's a -4 and a -7n. But this is a great way to look at it. Again, the identity property is n is the same as 1n. So you can just put a 1 right in front there. So just some things to rearrange before you start looking at the parts. So the terms, remember, each term is its own separate. So there's 4 terms. 6n, -7n, -4, and 1n are just regular n. The like terms are the ones that have the variable n. So 6n, -7n, and 1n are alike terms. They have the same variable. The coefficients, remember that's a number in front of a variable. And so that is 6, just 6. You leave the n out because 6 is the coefficient. The term is 6n. So it's 6, -7, and that +1 in front of 1n. Then the constant would be -4, the one without a variable. So you can give this one a try. Again, you can either just choose to look at it, looking at them with just a sign in front, or you could choose to chop minus, and then you'd see that this is the same as those terms as well. And so finding the terms, there's 1, 2, 3, 4 numbers separated by a plus or minus. And so those would be the terms. So we have our terms of 9y, -4, -11y, and 7. Our like terms are the terms with the variables. So our like terms here are going to be that we have 9y and -11y are alike, whereas, I'm going to make a line here to separate them for now, whereas -4 and 7 are alike because they don't have a variable attached to them, they're constants. The coefficients, again, are the numbers in front of a variable. So my coefficients here are 9 and -11. My constants are the numbers without a variable. So my constants are going to be -4 and 7. Again, you can try the next one, pause and come back. So looking at looking at them separated by the plus or minus signs, but knowing it's a sign in front, because you know that subtraction is actually the same as adding the opposite. So you need to know that those are actually negative numbers. So you can see that by doing this. So your terms, in this case, are going to be 3x, 2, -10, and -3x. Your like terms then are going to be the ones that have something in common. So 3x and -3x are alike because they share the variables, whereas 2 and -10 are just constants, so they're alike. You can combine those. The coefficients, the numbers in front of a variable, are 3 and -3. Remember, just the coefficient part, not the variable involved. And then the constants are the 2 and the -10. So not too bad. It's important to be able to identify the parts for that when we get into the combining part. So an algebraic expression in simplest form, if it has no like terms, and no parentheses. So if after you've combined everything that you can combine, then it's simplified. So we use the distribution property to combine like terms. This is simplifying an expression. So we find our like terms. 4 and y are like terms. In a longer one, I would just circle or underline the ones that are like so I know what to combine. So 4y plus y is actually the same as 4y plus 1y. And so the distributive property, it's really just like y's on the outside. So it's 4 plus 1 times y is the same as 4y. So there's a little sign on the side to check whether 4y plus y are 5y equivalent. Substitute any value for y to see if they go. So you could do a double checking. What they mean is you could plug in 4 times, you could pick 2 plus 2 is equal to 5 times 2. So if you're plugging in y for every part where y is, then you should end up with both things on the same side. So we get 8 plus 2 is equal to 10, and 10 is equal to 10. So that would be the same as 5y is what they mean. So again, simplifying the expression here, finding the like terms right away. So listing them out. What I like to do, and you'll see me do this, is I circle the like terms with the sign in front. And then sometimes if I circle with one, since you might not have another color, I square the others just to make sure that I can tell what is alike. And notice that's kind of the same thing that they did here, is just separating them out. So those are the like terms. You might have changed this using that definition of subtraction, doing the add the opposite. That's okay too. So doing that add the opposite so that you have which ones are negative is clear to you. So then you look for those like terms. So I'm going to combine 7x plus negative 7x. Using that distribution property, kind of ignore the x and just add the numbers together, which is actually 0x plus 4. And when you have 0 times any number, like here, that's actually just going to be 0. So this is actually just the same as 0 plus 4, or just 4. So what they did too was also, just to get that 4, just so you're aware, is combine negative 2 plus 6. And then that's a negative plus a positive. You have more positives. You have 4 more. Give these ones a try and then pause and come back and see if you got them. So we have 4z minus z, so that's going to be the same as having 4z minus a 1z. That's also the same as 4 plus a negative 1z. And then separating those out, that's the same as 4 plus a negative 1 times z, which is the same as 3z. Here, we did maybe add the opposite, so we see that we have a negative 3n. And then we have 6, and then we separate the like terms that we have, and we do the distribution. So negative 3 plus 3 times n, which is 6 plus a 0n, which 0n is going to just be 0, leaving us simplified with just 6. Same thing here, doing that definition of subtraction, adding the opposite to see the signs in front of the numbers. Finding the like terms, doing different colors. So 2g plus negative 8g is the same as 2 plus negative 8g times, or 2 plus negative 8 times g. And the same thing on the right with the negative 3 and 11. And then do negative 6g plus 8. And so that is just a negative 6g plus 8 simplified, because those terms cannot be combined any longer because they're not alike. With word problems, concerts. At a concert, you buy some souvenir t-shirts for $12 each, the same number of CDs for $7.50 each. So write an expression in simplest form that represents the total amount. So the sum number means we don't know how many we've bought. So we can do 12 times x from the number of t-shirts and CDs, since it's the same number. Since it's the same number, that variable can represent the same amount. $12 for each t-shirt and $7.50 for each CD. So since those go together, then we can actually combine these, since they're like terms, and end up that we're paying $19.50 for every amount if you put it as a combo. So the expression $19.50 times x represents the total amount spent. So another one, money. You have saved some money. Your friend has saved $50 less than you. That's important to read as less than you. Write an expression in simplest form that represents the total amount of money you and your friend have saved. So x represents your savings. X minus 50 is your friend's savings, because it's 50 less than you. So minus 50 from yours. So that means your savings plus your friend's savings, which then you would combine those like terms. Two x's there. And so you get 2x minus 50 is your simplified total amount. So rewatch this video, watch someone else's, check out the book examples and extra examples, personal tutor in your online textbook. Good luck.